Today we're going to be talking about linear systems of equations. By linear systems of equations, I am talking about a mathematical model that is comprised of multiple linear equations, an equation that doesn't have any variable with power higher than 1, and multiple variables. And our quest in a linear system of equations is to find some answer that simultaneously satisfies every single linear equation in our system. So, in the past, if we had two linear equations that we were trying to find an answer to that system, we could solve it easily graphically like we've done today. Today we're going to learn about a new method of solving linear equations. We have two new skills we're going to learn. We're going to learn all about substitution and all about elimination, both of which are some really cool algebraic methods to quickly and easily find a solution to one of these equations or one of these systems. So first, let's just remind ourselves what our solutions look like graphically. So if we were to graph our two lines in our linear system, we might come up with something like this. You'll see that these two lines intersect exactly at this point, so this is our one solution. And if we were to solve this algebraically, we might find something like this. X equals 2, y equals negative 1. So if we were to solve this algebraically, we got this, like, oh yay, we have only one solution. However, if we look over here at this one, we'll see these two lines never intersect, so we have no solution. If we were to solve this algebraically, we might get something like this. Negative 4 equals 373. That should be red flag because those are never equal to each other. So just like these two lines never intersect, negative 4 never equals 373, so voila, we have no solution. Now if we look here at our last example, you'll see that we graphed our first line, and then when we were graphing our second line, wow, it's the exact same line. This means that we have infinitely many solutions because our first line intersects the second line at every single point. So we have infinitely many solutions. So if we were to solve this algebraically, we might come up with something like this. 0 equals 0. And when does 0 equal 0? Always. So when does this line intersect the other line? Always. So this will tell us, hey, we have infinitely many solutions. So now let's look at our first skill, substitution. With these tools in the back of our minds, substitution is going to be a breeze. So now we're going to talk about substitution. In substitution, the first thing we're always going to do is to take one equation and isolate one variable. So let's kind of look to see how this would work out. So we're going to be talking about substitution. Substitution, like I said, we're going to take one variable or one equation and isolate one variable. So let's say we had a system like this. 3x plus 2y equals 5 and y equals 2x minus 8. Okay, so the first thing that we're going to want to do is we're going to take one of these equations and isolate one variable. But luckily, if we look here at our second equation, we'll see that y is already isolated for us. So they've already done some of the work for us. So let's take our first equation and use our substitution. So like the name implies, we're going to be substituting something. So we're going to take this value for y that we already know, and we're going to substitute it right on in here for y. So let's look to see what this would look like on over here. Taking our first equation, I'm just going to recopy that down. We have 3x plus 2y equals 5. And then we're going to want to do a little bit of substitution here. We see that y equals 2x minus 8, so we're going to want to use that information here in this one. So we'll have 3x plus 2 times, oh, what does y equal? Huh, funny you should ask. We know that y equals 2x minus 8. And then we still know that this equals 5. So all we did was substitute what we know y is equal to in here for y. So now all we have to do is substitute or distribute our 2 here and solve for x. So we have 3x plus 4x, which is 2 times 2x, and then 2 times negative 8 is negative 16. You know this equals 5. And then just solving this equation for x, we'll see 7x equals, add 16 to both sides, 21. Then x equals 3. Now we have one more substitution to do. So we can take this new value of x, which is 3, and then we can substitute into our second equation. So we're always going to make sure we're using both equations. So in our first step, we had used the second equation to solve for y. So now we're going to want to plug this back in so we can see what y is equal to. So let's do that on over here. So we'll see equation 2 is y equals 2x minus 8. Coincidentally, we already know what x is equal to, so we can take y equals 2 times, what is x equal to? 3 minus 8. So we'll see y is equal to 6 minus 8, and finally y is equal to negative 2. So there we go. We have solved the linear system, and we know our final answer is 3, negative 2. Now let's check to make sure that we have the right answer. We could have messed up somewhere along the way, so we can always check our answers with these linear systems of equations. So how we can do this is that we can take this value of x and plug it into x for both equations and y in for both equations to make sure we get the right answer. So let's check with equation 1 first. So we have 3x plus 2y equals 5. So 3 times x equals 3 plus 2 times y equals negative 2 equals 5. So then we see 9 minus 4 equals 5. And we know, voila, 5 equals 5. Now if we try here with the second equation, y equals 2x minus 8. Then we know y equals negative 2. So negative 2 equals 2 times x equals 3 minus 8. And then we're left with negative 2 equals 6 minus 8. So negative 2 equals negative 2. So then we see, wow, we have found the correct answer because these equalities stand true. So this one is a little easy because they already gave us what y is equal to. So let's try one that makes us use our powerful algebra skills that we all know and love. Okay, for our next example that might be slightly more tricky, let's take a look at this example. If we have the two linear equations, negative 12x plus 3y equals negative 6, and negative 8x plus 2y equals 14, we need to do the same kind of way that we always start a substitution problem and take one equation and isolate one variable. So this time we actually have a choice. We don't have a y handed to us on a silver platter. So we can either choose our first equation and solve for x or solve for y, or we can choose our second equation and solve for x or solve for y. So for kicks and giggles, let's just take our first equation and solve for this x. So let's just take this first equation on over here. So we take equation 1, and we're just going to copy it down here. And now we want to solve for x. So all we have to do is do our basic algebra, get x by itself. So subtract 3y from both sides, we'll have negative 12x equals negative 3y minus 6. And then we divide both sides by negative 12, we'll end up with x equals 1/4 y plus 1/2. Okay, so now we have found what x is equal to, and now we can do our name of the game, substitution, and substitute this value of x in. Now we wonder, okay, which equation do we sub it into? We've already used equation 1, so now we have to use equation 2 because we're solving a linear system, not one line. So let's substitute right on here too, on this side over here. So we'll take equation 2, and we're going to be substituting in our value of x. So we'll just copy down the equation first of all. And now what is our x equal? So we have 8, and our x is equal to 1/4 y plus 1/2. So let's put this in here. And then we still have everything from our second equation. Okay, and now all we have to do is distribute our negative 8 and solve for y. So we'll just do that. So we have a negative 2y minus 4 plus 2y equals 14. We'll see that when we combine these two like terms, we're left with 0y. So we just have negative 4 equals 14. Wait a second, this looks familiar. When we have two numbers that definitely do not equal each other, because negative 4 never equals 14, this should remind us, okay, we have no solution because these two are never equal to each other. So we know that this actually has no solution. And this means that there's no value of x with a value of y that will satisfy both of these equations at the same time. So now that we have mastered substitution, let's try a couple examples with elimination.